All right, hello. This is Aaron Helander for Aaron and Ryan Emery. We're going to be going through our presentation here for the second time now, because the first time I did it, I exited the Camtasia app and completely lost all the work I did presenting this last time. But I am more than happy to go through this again and hopefully actually save it correctly this time. So our project name is Statistical Swimming, and really this project aims to find out who the best swimmer is, because swimmers are constantly arguing about who it is, who their favorite ones are, who's better than who. And this may seem like a very simple problem to solve. We can compare swimmers based on time, but how do you really compare them year to year? Because swimmers in the 1920s did not have the same advances in technology and coaching that we do here, so it's not really an apples to apples comparison when you're comparing swimmers across different years or even swimmers across events. If you're comparing a butterfly to a breaststroker, how do you actually compare who is the better swimmer? So our solution, we need to compare swimmers using a standardized method. So we had to reach back into our stats class and pull up z-scores, which is great because we can actually show this graphically. So it gives a nice visual component of our project, so we can look at the data and compare them graphically. And then we can see how far ahead someone is relative to the average. So that's where the z-score comes in. How many standard deviations are they faster than the people of their year in their specific event? So what did we do? We had to clean up the messy data because we downloaded 6 years of information from the internet. We had to combine it in the 6 different Excel worksheets into one. In the worksheet, the last name and first name are in the same column, and we had to separate that so we could do more of the qualitative looking and comparing of the swimmers. We had to create an age range with a relative V lookup. So this isn't your standard V lookup. We had to do it relative because it's not a specific number. It's actually a range, so we had to get to the relative V lookup. And these couple formulas we're going to get into, we'll go check those out in our Excel workbook as well. We had to find the overall rank relative to the rank by year, so comparing the swimmers as well. We can compare all of them, and then we can compare them year to year with their z-scores that way. And then we got to create a unique identifier with concatenation. So just another cool thing that we learned in the class that we're able to utilize in our project to give a unique identifier. So for our data analysis, we found descriptive statistics for all the different rankings. We use this to calculate the z-scores, which gives us that standardized mode of comparison. And then we also wanted to see the descriptive statistics for the top 20. So looking at things like what swim program are these people coming from. We want to see who is on the list multiple times. So in these 6 years, how many times did they make the list? What was their positioning in those years? And we can compare it that way. So here's an example of our statistics. We get our mean, standard error, all these fun items that we learned in stats class. And, we would expect for this data to all be trending down every year, people getting faster, getting better. Where it is starting to trend down just in this small sample, but 2016 is really the fastest year. And, we had to think why that is. And the reason, of course, being is because 2016 is an Olympic year. So people are swimming their best then. And the reason why 2020 is slower now is because we haven't we just started the season, the 2019 to 2020 season, so people haven't swam their best times yet. Surprise! Another cool find that we found. So, going into this project, we thought people age 18 to 24 would be the fastest in this age group. Kind of the prime of their physical health. They're in collegiate programs and then going to the Olympics. But actually, the 30 and above age group was the fastest. And the reason for being is because there's not a lot of swimmers above 30, and the ones who are really good and get paid lots of money to keep swimming, and they're the people like Michael Phelps who bring that average down for the 30 above age group. So if you're above 30, there's hope for you. So here's just a couple of demos of our prototype. You can see here we have the different mean and standard errors for the years, so we can compare z-scores from year to year. We also just wanted to look at the top 20 stats, see where they are in relative to the overall statistics and how much better they are, how much closer they are, and the difference between the minimum and maximum, which you can see here, quite the difference here. So here's just a little snippet of our first name, last name that we had to separate. Here's where we use the relative V lookup to find this. And then look at this. This swimmer here, Caleb Dressel, is almost 3 z-scores away, which is wild compared to the rest of the field. And then here's his unique identifier that we used during concatenation, and we'll take a look at that here very soon. So capabilities and limitations of this project. We are able to analyze the relationship between age, team, year, and their time. So that's all using our pivot table. We can use this analysis to compare any swimming event, which is great to compare breaststrokers, IMers, butterflyers, freestylers. We can also see who had the fastest time per year and how many times they were on the list for those different years. And we can see how individuals progress as they get older, and that's doing the descriptive and qualitative analysis. A couple limitations with this project is that we were exporting the data from a website into Excel workbook. So if you're looking at many different years, you're going to have to condense all those worksheets down, and there's only so much that can be done in Excel. We only looked at 6 years of data in this specific example just to give a sampling of what can be done and to show what we can do. So we can't draw huge conclusions just from this one. And something that would be interesting to look at to see people who rank in the top 20. Our worksheet here doesn't account for gender, height, weight, length of career, and etc., which would be interesting variables to look at as well. So our challenges, everyone wants to know the difficulties we did going through this project. Was really exporting the data from the website into an Excel workbook itself, combining those 6 years of data. It was a project of itself. The time column was in the seconds and the hundreds of seconds format, and it automatically want to convert itself to the number format in calculations and functions, which we did not want to do because we are looking at seconds, which is different than if it's a relative number. We had to find the comma position in the full name because the first and last name were in the same cell, and we wanted to separate those two out. We created charts that had minimum time, but they were often wanting to do the summer average, so we had to make sure that they did not do this so we could actually compare them. And then, as I mentioned previously, we created age range using a relative VLOOKUP because we had to find out in the different couple year age spread, not just an exact age. So now I'm going to jump on over to our worksheet here. So you can see over here, this is where we got statistics. That's what we had on our presentation here. Here is where our graphs are. So again, I done this and just deleted it, so I'm doing it over again, but we can see which teams produced the number of top 20s swimmers. We can see the swimmers that made it for multiple years, how many times they made the top 20 records in these 6 years. So Joe Schooling made the top 24 times in these 6 years. Impressive. So the top 20 times, so yep, this is our biggest age group, and these outliers over here are fast. And then up here we can see, if I can get up here, we can see that the top 20 times, we have our unique identifiers here, and we can compare the times, and you can really see this is the 2.79 standard deviations away from the average of all the fastest swimmers here. So this is our master sheet of our data. And here, this is where we're going to get into our formula. So finding the comma position, so we can separate out the name. So once we found the comma, we can go into the trim and use the mid function here to get the first name. Then we use the left function here to get to the last name. This is where our relative VLOOKUP comes in, so we can find this age range, 13 to 17, 18 to 24, not just one specific age, but in the age range. That gives us our rank, the z-score, and here's our fun concatenation formula to create a unique identifier to them. So you can see the first name, last name, and where they're from. And on this side, we had our pivot table, which we can move around and compare the different names. We can sort them and find the different variables that go into it. Well, I hope you enjoyed and that you learned something here, and I hope to see you again very soon. Have a great day.